All right, let's jump right into this explainer. Today, we're diving deep into the hidden machinery that powers, well, literally everything around us. We're going to uncover the invisible architecture running our physical, biological, and even our digital worlds. Now, think about this for a second. What on earth could a heavy piece of automotive metal possibly share with the microscopic ecosystem in your stomach or the code powering a supercomputer? It sounds like a trick question, right? But the answer actually lies in the fundamental principles of interconnected parts driving a much larger machine. You see, from forging matter in the intense heat of dying suns to spinning galaxies, and eventually evolving human consciousness just to do something as simple as bake an apple pie, everything operates as a complex, interlocking system. It's all cause and effect, driven by distinct cosmic gears. So here is our roadmap for today. First, we'll cover the fundamentals of physical gears. Second, advanced kinematics and mechanisms. Third, biological and neural gears. Fourth, the architecture of AI. And finally, AI's impact and future. Okay, part 1, fundamentals of physical gears, the tangible machinery. To really get this, we have to start with kinematics. Basically, this is the pure study of motion. It gives us the vocabulary to discuss how any system actually operates. We aren't worrying about heavy forces or weight just yet. We're looking purely at the geometry of how one part inevitably moves another. It's kind of like tracing the exact predictable path of a falling domino. You know, it's wild, but simply changing the angle of a gear's teeth completely alters what it can do. Take standard spur gears. They have straight teeth. They're simple enough, but at high speeds, they absolutely scream with noise. But if you shift to helical gears, where the teeth are cut at an angle, multiple teeth engage at once. This creates that whisper, smooth operation you absolutely need for something like a high-speed vehicle transmission. It's the classic rule, form always follows function. Look at bevel gears. They intersect at 90 degrees, which is literally perfect for splitting power in a car. Worm gears act like screws for massive speed reduction, perfect for driving heavy factory belts. A rack and pinion brilliantly translates the turn of your steering wheel into the linear movement of your tires. And hypoid gears, they allow for offset shafts to keep heavy trucks from flipping over. Every single shape solves a very specific physical problem. Moving on to part 2, advanced kinematics and mechanisms, the complex and invisible. So, if we leave that heavy steel behind and zoom way, way down, we find that invisible, microscopic nanotech structures and chemical regulatory networks act just like tiny, complex machines. In synthetic chemical networks, enzymes act exactly like gear teeth. One chemical reaction triggers another, complete with built-in feedback loops that inhibit or activate the whole system to produce a highly controlled output. Which brings us to part 3, biological and neural gears, the human machinery. Because yeah, your own biology is basically a massive gear train too. Take your gut, for example. The specific balance of bacteria in your gut acts as a physiological dial, directly influencing systemic issues like insomnia and sleep apnea. An increase in one type of bacteria effectively turns a gear that disrupts your circadian rhythm. Your gut is literally turning the gears of your brain. And it gets even cooler when we look inside the brain itself. To drive human creativity, your brain actually shifts gears between 2 core networks. During idea generation, the default mode network runs freely, daydreaming, making novel connections. Then a switchboard called the salience network engages a second gear, the executive control network. This gear refines the idea and focuses on decision-making. You literally have mental gears shifting back and forth to produce innovation. All right, zooming back out for part 4, the architecture of AI, the digital machinery. So when we stack up our human biological gears against the digital gears of AI, one huge difference jumps out, and that is efficiency. We humans use our emotions as a biological value function to make really robust decisions from very little data. AI, on the other hand, currently requires a massive 10,000 hours of reinforcement learning practice to achieve that same robustness. They are 2 wildly different mechanisms aiming for the exact same output. But if you actually look under the hood of AI-driven research, you'll find a highly structured kinematic chain. It ingests millions of papers, clusters them by topic, analyzes citation networks, detects missing methodologies, and maps temporal trends. Every single step is a gear forcibly turning the next, grinding raw data into actionable knowledge. Think of this whole pipeline as a high-speed digital mechanism. Semantic similarities get grouped into vector embeddings, passing along the chain until a highly refined output emerges. What you get is a ranked list of unexplored, high-impact research areas that are ready for human evaluation. And the torque this digital machine applies is just staggering. We're talking about a 500 times speed up in processing. To put that into perspective, an AI can digest 5,000 complex papers in roughly 5 hours. That is a task that would take a human over a year of full-time reading. This velocity has already identified 200 understudied proteins and found 12 new drug candidates for diseases we previously thought were intractable. Which brings us to our final section, Part 5, AI Impact and Future. Basically, where all these gears are turning. The velocity we're going to see over the next few years is wild. By 2026, autonomous agents are set to seriously shift our economy. And by 2030, we are looking at driverless taxi fleets, lifelike AI companions, personalized AI tutors, and even AI co-pilots for jets. The machine is actively accelerating right before our eyes. We started today by looking at how we humans built physical gears to overcome our own mechanical limits. But now, we're building digital gears that vastly exceed our own biological processing speeds. Which leaves us with a pretty provocative question to chew on. As this entirely new kinematic chain accelerates, are our biological gears destined to be outpaced, or are we simply becoming a smaller cog in the ultimate machine? Thanks so much for joining me on this explainer.